Hey guys, and welcome back. So this is day 2 of solving systems by elimination. On day 1, we found that we needed to get an opposite pair. And in all those examples, we either had an opposite pair or we were just off by maybe a negative. Today, we're going to look at what happens when it needs a little bit more than just multiplying by a negative. So our goal is still going to be the same. We want to get coefficients that are opposite pairs because that's what we'll eliminate. And we're still going to have the same steps. We're going to multiply, then we're going to add, then we're going to solve, substitute, and solve again, and then write our answers in ordered pair. We will today come up with some special cases. And that's going to happen when the variables and the constant cancel out to leave you with 0 equals 0. And that'll give you infinite solutions. Or the variables are going to cancel out, but the constants are not going to cancel out, leaving us with 0 equals a number, and that will lead us to no solutions. So let's first take a look at number 5. When I look at number 5, I see that in my coefficients of my variables, I do not have an opposite pair. My constant has an opposite pair, but that's not necessary. We don't need to worry about that. We need to look at our variables. I also can see that I can't just multiply 4 by something to get 5 or 5 by something to get 4. I can't multiply 3 by something to get 4 or 4 by something to get 3. So I can't just multiply one equation by a single number and achieve my goal of having an opposite pair. It is important to note that you never want to multiply a bigger number by something to get a smaller number. We always want to go with a smaller number to get a bigger number. And that's because to go from a bigger number to a smaller number, we would end up having to divide or use a fraction, and it's much easier to not deal with that. So you can do this in a couple of different ways, but the best way is to take whatever is on your x's and flip-flop them. So the 5 was the coefficient of the bottom x, so I'm going to multiply the top by 5. And likewise, the top had a coefficient of 4, so I'm going to multiply by 4 on the bottom. That will make it so that both 4 and 5 multiply to get 20, which gives me a 20x. Since they're both positive, I need to make one of the numbers I'm multiplying by negative, because that will achieve my opposite pair. It does not matter which one you make negative. So when I multiply negative 20 in through the top, I get negative 20x minus 15y equal to positive 5. On the bottom, I will get 20x plus 16y equal to 4. Now I can see that I have my opposite pair that I wanted. Since I have an opposite pair, I can go ahead and add my two equations together. So negative 20x plus 20x gives me 0x. Negative 15 plus 16 will give me a positive 1y. And 5 plus 4 will give me 9. The 0x then cancels, leaving me with 1y equal to 9, which is just that y is equal to 9. Just like in day 1, 9 then just needs to plug right back into y. I'm going to put it into the bottom. It doesn't matter if you put it into the bottom or the top. So I have 5x plus 4 times 9 equals to 1. 5x is equal to, 5x plus 36 is equal to 1. Minusing the 36 from both sides, I get that 5x is equal to negative 35. So x is equal to negative 7. Again, we still have the lines that are intersecting, so my answer is an ordered pair of negative 7, 9. The only thing we're changing is that we really do need to multiply at first in these problems. Once we've multiplied, everything is the same as we did on day 1. Now let's take a look at number 7. On number 7, I see that I don't have an opposite pair, but I do have a set of variables that has different signs. I can also see that since there's that negative 1, I can go ahead and multiply that by 4 and have 4y, and I only need to multiply the top equation. But I could also very easily just flip-flopped my 3 and my 5 and done this one like I just did the last problem. It's whatever you see in the problem that matters. So I'm going to go ahead and multiply my top by 4. So that's going to give me 12x minus 4y equals to 56. Carrying down my bottom equation, I have 5x plus 4y is equal to 12. Since I now have an opposite pair, I can go ahead and add my two equations together. So I get 17x plus 0y is equal to 68. I can then bring down 17x equal to 68. And then I know that I'm going to divide both sides by 17, which is going to be 4. Then I'm just going to take my x equals 4 and just plug it straight back in. I'm going to actually do this one on the top. So I'm going to have 3 times 4 minus y is equal to 14. So 12 minus y equals 14. Minusing 12, I get negative y equal to 2, so y is equal to negative 2. So my final answer is 4, negative 2. Now let's take a quick look at some special cases. When I look at number 4, I see that I don't have an opposite pair. I don't have a number I can multiply by another number to get the other equation. So like I can't multiply 2 by anything to get 5 or 8 by anything to get 20. So what I'm going to do is just go with my first strategy where I'm just going to multiply the top by 5 and the bottom by 2. Since I already have different signs, I don't need to worry about changing them. So I want to keep my numbers that I'm multiplying by positive. So that'll give me 10x plus 40y is equal to 30 on the top, and the bottom will become negative 10x minus 40y equals to negative 30. Now I see that I have a lot of opposite pairs. So I'm going to go ahead and add my two equations together. So 10x plus negative 10x is 0x. Plus 40y plus negative 40y is 0y, and 30 plus negative 30 is 0. So this is a case where my variables canceled and my constant canceled, giving me 0 is equal to 0. Since that's a true statement, I know that I have infinite solutions. So this is one of my dependent systems where they are actually the same line. Let's take a look at number 9. I can see that I have almost an opposite pair. My x is a positive 1 and my x is negative 2. Or my y is negative 1 and my y is positive 2. Those are both easy to make an opposite pair out of. All I need to do is multiply the top by 2. So that will give me 2x minus 2y equals to negative 4. On the bottom, I'll have negative 2x plus 2y equals to 2. Now that I have my opposite pair, I can add my two equations together. 2x plus negative 2x is 0x. Negative 2 plus 2 is plus 0y. And then negative 4 plus 2 is negative 2. So I can see that my variables have canceled, but my constants have not. Since that's the case, then I know that this is no solutions because 0 does not equal negative 2. That means that these are two lines that are parallel and thus will never intersect. I want to talk about one last question, and that is number 6. When we look at number 6, we don't see any opposite pairs or any numbers that will multiply to be each other. So I am simply going to multiply my top by 4 and my bottom by 3. I'm trying to eliminate my x's. So since they have the same sign, I need to make one of the numbers I'm multiplying by negative because that will achieve an x that has opposite signs. So negative 4 times 3 is negative 12x. Negative 4 times positive 3y is negative 12y. And negative 4 times negative 15 is positive 60. On the bottom, I'll have 3 times 4x, which is 12x, 3 times negative 4, which is negative 12y, and 3 times 36, which is 108. While it looks like I have multiple opposite pairs, I actually only have one pair of opposite numbers. I have negative 12 and positive 12x. That gives me 0x. But my y has negative 12y and negative 12y, which is actually negative 24y. Since they're the same sign, we need to add them. They're not an opposite pair. Then 60 plus 108 is 168. This leaves me with negative 24y equal to 168. I can then divide by 24 on both sides by that negative 24, and I'll get that y is equal to 7. Once I've done that, I can take my 7 and plug it back into y in either equation. So I'm going to have 4x minus 4 times 7 equal to 36. Completing my multiplying, I get 4x minus 28 equals 36. Adding 28 to both sides, it's 4x is equal to 64. Dividing by 4 gets that x is equal to 16. That leaves my final answer as 16, 7. So make sure that you are extra careful to watch your signs and make sure they are indeed an opposite pair before you cancel them out. I hope this was helpful, and if you have any questions, please make sure to ask. Have a great day.